Space Technologies under the ISTIC 2025. Before proceeding, I would like to invite on dais Shri Kiran Kumar, Member Space Commission and former Chairman ISRO, Dr. V. Narayanan, Chairman of ISRO, Secretary DOS and Chairman Space Commission, Shri A. Rajarajan, Director of Vikram Sarabhai Space Center, Professor Sanjay Mittal from IIT Kanpur, Ms. Jayanti Bhagta, CEO of JBI Aerospace, and Mr. John Paul, CEO, Missitech. Ladies and gentlemen, for steering and overseeing the entire activity of space technologies theme of this important conclave, a committee was constituted under the leadership of Shri A. Rajarajan, Director of VSSC, and committee had a very eminent personalities as a member, Dr. Anil Bharadwaj, Director of Physical Research Laboratory, Mr. Shantanu Bhattavadekar, Senior Advisor NCIL and former Scientific Secretary, Mr. Senthil Kumar, Deputy Director of Space Applications Center SAC, Dr. BP Saha from ARCI and Bhupinder from DST, and myself, Dr. Rajiv Jaiswal from ISRO as a member secretary. Committee had several rounds of meeting to work out the vision and expected outcome, and entire thing had been worked out under the valuable guidance of Secretary Space. Now I invite upon the thematic committee chair, Shri A. Rajarajan, to brief about the thematic session and set the tone for today's discussion. As you know, Shri Rajarajan is an expert in the area of composites and structures. Formerly, he was the director of Satish Dhawan Space Center, Sriharikota, which is known as the Spaceport of India, and currently he is a distinguished scientist and director VSSC. Over to you, sir.
Thank you, Rajiv. A very good morning to one and all, especially for a distinguished guest on the dais, respected Chairman, Secretary, Department of Space, Dr. Narayanan, former Chairman ISRO, Sri Kiran Kumar sir, and my mentor, and Professor Sanjay Mittal, Jayanti ma'am, and John Paul, and all the dignitaries who are assembled here. It's always a pleasure to speak to you today at this important space technologies thematic session of Emerging Science, Technology and Innovation Conclave 2025. We try to, this theme session, we aim to foster the synergy among diverse stakeholders to drive the collaborations to realize the ambitious vision of Vikasit Bharat 2047. What we have thought during our thematic sessions, numerous sessions that we had, is behind this vision is that space technology should be the catalyst for the innovation and contributing to the advancement in various fields because of the niche area and the technicality that is required in this area. The focus should be on self-reliance, creating job opportunities, positively impacting the local economies, and to showcase our indigenous capability and development. And it should be aligning with the national development goal to contribute for becoming a developed nation by 2047. Taking these things into note, this session will be consisting of two parts: a technical session, which will consist of talks by experts, and a moderated panel discussion. So we identified keynote to be given by none other than Dr. V. Narayanan, Secretary, Department of Space and Chairman ISRO. He's an eminent personality in the field in many areas, and especially everybody knows the indigenous cryotechnology is possible only by him, made possible only by him in India, which we are using it. And we can't think about, when we are looking at what space technology to make India proud to be a Viksit Bharat by 2047, for providing the insights and perspectives on this thing. Then, after that, the expert talk will be by Professor Sanjay Mittal, a renowned accommodation from the Aerospace Engineering Department of IIT Kanpur. And we also have an woman entrepreneur, Ms. Jayanti Bhagata, who is the CEO of the JBA Aerospace and puts a lot of innovative projects. Her thought process is something always different from the normal tradition that you will be listening to her. Then Dr. John Paul, the CEO of Misitech, representing the deep tech as some niche technology and looking at how we can look at the glass and other areas where we are still we are looking at outside resources, how to do it within the country. So considering all this, we have requested our former chairman, ISRO, Sri Kiran Kumar Sir, to chair this important thematic session and guide us through this with his vast experience. One of the mentor gurus who always makes we vibrant people resonating in very, very distant, discordant manner. He always is a calming person who puts us in the right path. Similarly, for the panel discussion, and moderators and panelists has been identified from startups, industries, enablers, and government to foster the collaboration across ministries, academia, and industry. The session will be moderated by Mr. Shantanu Bhatwardkar, the Senior Advisor NSL and the former Scientific Secretary of ISRO. And it includes me, besides me, Mr. Balaji, the person from Aerospace Division NAL, Mr. Rajiv Jodhi, the Director of the Technical Department from InSpace, Mr. Pranit Mehta, the co-founder of Galaxy Space, and I hope that also will be enriching to you. Now, from now onwards, I request Sri Kiran Kumar Sir, the session chair, to make his valuable opening remarks. Before he starts, it's my duty to say a few words about him. Kiran Kumar Sir is a member of Space Commission. He was chairman and secretary from 2015 to 2018, guided many of the NAVIC and spearheaded areas. He is a highly accomplished space scientist and engineer with a distinguished career spanning over 4 decades in ISRO in the satellite payload and application domains. His contributions are so immense. The people that he has mentored and brought us is so much. We lose count of how many people have come to able to do in these various domains all across India, and still puts tremendous effort in making sure that India becomes well self-reliant in many, many areas. And his contribution in the design and development of the imaging sensor and payload for geostationary orbit is, I could say, is a legendary. And for him, we always indebted to him for the development that we have made, not only in ISRO, but in the country as well. So over to you, sir.
Good morning to all of you. Indeed, it's a great pleasure to be present in this a very unique event where Emerging Science, Technology and Innovation Conclave for India Space Vision 2047 Challenges and Way Forward. If you really look at when humanity got a new capability, of new technological capability of going beyond Earth, we had in India great visionary people like Dr. Sarabhai, who could think of how this new technological capability can be made use of to foster the development in the country by bringing in broadcasting, communication, weather monitoring systems. And over a period of 5-6 decades, India is where it is today, among the few countries in the world which have an end-to-end capability of building launch vehicles, satellites, and application. And more than anything, make use of this technology for solving problems of the country. And in the past decades, we have seen India has grown from its very low position just after independence to fourth largest economy. And in the future, by 2047, when the vision is to be among the top, what needs to be done is not only look at how things have happened in the past, and between now and the remaining period till 2047, how we should actually make use of technologies for solving problems which we are facing today. In fact, last 2 days, you have seen that adoption of new technological capabilities to address specific problems we are facing is the way to go forward. And while we do that, time has come where we cannot depend only on what has been done elsewhere and adopt them, but we need to develop our own new capabilities, not only becoming self-reliant in the current geopolitical situation, but also ensuring that we address problems of not only India, but also global humanity. And if that has to happen, it's only possible when you do what is given as the imagine, innovate, and inspire. And what is planned in these last few days here, the very first ST conclave, is to bring in the next generation and a lot of scientists and engineers across the country, give them a glimpse of what has happened, what is happening elsewhere, and then pose the problems and focus on solving the problems we are facing in the coming decades. And in this context, today, in this particular session, you will have the privilege of listening to Dr. V. Narayanan, who is currently the Chairman and Secretary of Department of Space, how India's space vision, which in the earlier era was primarily concentrating on addressing the ground problems, but as you keep moving up the ladder, you also need to make sure that you make use of all the technological capabilities to preserve, protect, and also ensure that you are among the top few. And Dr. Narayanan is going to give us this vision of what is being looked at and how India's Space 2047 will be achieved. And among others, as already pointed out, we'll be listening to their thought processes. And let me take this opportunity to complement the concept of this particular conclave, and then bringing all the people and showcasing to them that India has excellent examples of how it has made use of technology which is developed elsewhere to solve the problems of our country. But now, as we move forward, not only should we continue to adopt this, but also we need to develop our own capabilities, and which this land has shown for many centuries earlier. Now it is time to look back and then adopt them and bring solutions which will enable the humanity to survive on this planet. When you are looking at taking humans to space and to take them beyond Earth, all these becomes challenges, and how these challenges are going to be met is what we will listen to in the coming few minutes, and then wish you all a great listening in this process. Thank you.
Thank you, sir, for your insightful opening address, highlighting the crucial role of space technologies for achieving the Viksit Bharat 2047. Now let's watch the small video which has been prepared for the vision of this important session. Can we have that video?
From humble beginnings in a church courtyard to reaching the farthest frontiers of space, India's journey is a testament to vision, grit, and limitless dreams. It was Dr. Vikram Sarabhai who dared to dream that space technology must serve humanity and empower a nation. From Aryabhatta in 1975 to Chandrayaan, Mangalyaan, and Aditya L1, every mission has carried the heartbeat of 1 billion aspirations. India has built and launched over 130 satellites, powering telemedicine, disaster warning, navigation, weather forecasting, and resource management for millions. We turn challenges into triumphs. From mastering cryogenic propulsion to delivering cost-effective lunar and Martian missions admired across the world. When Chandrayaan-3 touched the Moon's south pole, India touched history. When Mangalyaan reached Mars in its maiden attempt, we proved that imagination knows no boundaries. Gaganyatri Shubhanshu Shukla carried India's dreams to the International Space Station. The journey ahead is even bolder. Gaganyaan, India's human spaceflight mission, and the development of super heavy lift rockets to take us to the Moon and beyond. Through missions like NISAR with NASA, LUPEX with JAXA, and a growing private sector ecosystem, India is shaping the future of space for all humankind. From courtyards to cosmos, from satellites to space stations, India's story has just begun. The stars are only the start. Expanding horizons through India's leadership in space technology. Igniting the spirit of innovation. ESTIC 2025. Imagine, innovate, inspire for Viksit Bharat 2047.
Now I request Sri Kiran Kumar sir to conduct this session, sir.
Yeah, now we will have the pleasure of listening to Secretary Department of Space on the plan for up to 2047.
Most respected chairman of this session, and Dr. Kiran Kumar, who is currently the member of the Space Commission, former chairman ISRO, Secretary Department of Space, and currently the chairperson of the PRL Governing Council, one of our mentors who have really groomed a lot of leaders of ISRO, distinguished personalities and panelists on the dais, and secretaries of various departments, and dear friends, very, very good morning to all of you. First of all, let me thank the organizers for giving me this opportunity to present on the topic India Space Vision 2047, Challenges and Way Forward. And I think already Kiran Kumar sir has already summarized. The space program was started by the visionary leader, the father of Indian space program, with a couple of his colleagues, Vikram V. Sarabhai. And the vision was very, very clear, and we should be second to none in bringing the application of the advanced technology like space technology to the benefit of the common man of the society. And to do that, basically we need three major systems. We have to build satellites of different types, different capabilities. And for placing the satellite, we have to develop launch vehicles and the ground systems for enabling the launches, also utilizing the satellite data. And all these developments concurrently started. That is the reason today, after 63 years, when you look at the space program, we are in a very, very comfortable state, serving the common man of this country, always also the global community in a big way. Now, historically, if you see the space activities, it was started in the year 1962 in a small place called Tumba near Thiruvananthapuram in Kerala. And there are major milestones. The first major milestone was 21st November 1963, the first tiny rocket lifted off from Indian soil. That rocket was given by USA, and the payload came from France, and we assembled in the church building, and it was lifted off. And from that humble beginning, today we have come a long way. And next milestone was 1969, 15th August, ISRO was formed. First 10 years, ISRO was, Indian space activity was with the Department of Atomic Energy. Then 1972, it became a separate department. From 1963, at that point of time, we got a tiny rocket from USA. Today, when you look after 60 years, This year, July 30th was a very, very historical day for India. And when we got this tiny rocket, we were truly 60 years behind. And in the initial phase, we used to move our rocket in the old bicycle. I think you are seeing the photograph of the bicycle. This year, we had an important milestone, a launch of NASA ISRO synthetic aperture radar satellite, a 10,300 crore investment made by NASA for building a payload, L-band SAR payload and the antenna. Also, we have made a equivalent payload with 1/10 of the cost, S-band SAR payload, and the entire satellite was built by India, by Indians in India, and successfully lifted off, placed in the orbit. Now it is a significant growth, getting a tiny rocket. Today we are shoulder to shoulder, contributing for the space program along with the global community. Now look at, this is the overall organization structure. I am not going to dwell. We are directly working with the Prime Minister. And then we have got the ISRO centers responsible for the development activities. And we are having the autonomous bodies and in-space system for promoting and hand-holding the private sector. And we are having, again, the commercial wings like NCL and Andrix. And the sanctioned manpower is 20,000. It is almost constant during last 10 years. There is no growth, but activities growth is almost, I will say, 300% growth during last 10 years. And we have got 43 offices located in 22 locations, supported by 450 Indian industries, 130 academic institutions. Also today, we are having a space ecosystem growth, something around 330 startup companies in the country. And even though the annual budget is something around 13,500 crore, the approved project budget available is something close to 1,10,000 crore is the approved project budget. And we execute the entire space activities under 6 verticals: space transportation system, space infrastructure system, where we deal with all satellites, space applications, human spaceflight program, capacity building, where so much infrastructure is built in the country. And recently, this year, we have also brought one more system, the space science and astronomy, to give importance for that important activities. Now, the entire accomplishment from 1963 to till today, whatever is done is brought in the single slide. And in fact, 1963, November 21st, first tiny rocket lifted off. From that, 4,014 sounding rockets have been lifted off from Indian soil. Almost 70% belongs to India and 30% belongs to other countries. And we have realized, conceived and developed 6 generations of launches, starting from SLV-3 to SSLV. And we have accomplished till today 103 missions, 102. One mission we accomplished very recently, day before yesterday. And 134 satellites are conceived, built, and placed in the orbit. And 433 satellites of 34 foreign countries are launched from Indian soil. And now if you see the growth of the space sector, last 10 years it is exponentially, continuously exponentially growing. And last 10 years, for example, if you take 2006 to 15, 30 launches, now this 10 years, almost 61 launches. And next 10 years, it will be 120 launches. That is the type of target. And same way satellite is also, the growth is, it is growing. Now coming to the applications, the first experiment was demonstrated 50 years back, 1st August 1975. 2,400 television sets were kept in 2,400 villages of 6 states in India. And through a ATS-6 satellite signal, that too, again that satellite signal came from USA, we demonstrated mass communication in this country. From that humble beginning, today there are 50 plus applications in various domains. Earth observation, we contribute for food security, water security, environmental monitoring, ocean application, potential fishery zone monitoring, meteorological applications. And SATCOM, there are a lot of applications including television broadcasting, teleeducation, telemedicine, search and rescue operation, and NAVIC application. Today, something around 8,700 trains are real-time tracked, and 35,000 shipping vessels are tracked real-time, and lot of automobiles are tracked. And in another couple of years, entire systems are going to be tracked in real-time. Disaster warning and mitigation is yet another major area of application. In fact, there was a time there used to be a disaster, we used to lose 10,000 plus that type of people, citizens of India, we used to lose. For example, Odisha, there was a cyclone. The numbers, the last was more than 10,000. And when we had the tsunami 2005, my village is hardly 1.5 kilometers from seashore. I have gone and seen with my own eyes. The type of loss was huge. But today, I will not claim that we have solved the entire problem, but fairly we have reduced the problem, and the loss is to some lot of level it is reduced. And strategic application, it is also one of our responsibility to use satellite system for ensuring safety and security of every citizen of Bharat, and we contribute significantly in that area, including the recent Sindoor operation we have done, whatever best possible through the satellite system. And there are 50 applications when you talk. Today, I cannot think about a society without satellite applications. I think weather forecasting is yet another important thing, even though core responsibilities with Earth Science Department, our satellite data is crucially required for having accurate weather prediction. And I think I am not going to dwell on this because it will take a lot of time. That my time originally from 30 minutes, it is already reduced to 20 minutes, so I will not dwell on this application. Coming to space science area, it is yet another important area. Till now, 10 satellites are launched for space science-related activities. Currently, 4 are in operation. It started with Aryabhatta and Chandrayaan-1, and which has found water molecule on the moon, along with USA. Then Mars Orbiter mission, and it was a very, very important mission which was accomplished, and lot of achievements through that mission. And AstroSat, it has served 10 years successfully the life. It has worked. Now also it is continuing its operation, and lot of discovery has come. And Chandrayaan-2, we have placed the best camera in the moon orbit, and we are having the best photographs from moon, doing lot of scientific activities, lot of research is going on. Chandrayaan-3, we landed first time successfully near the south pole of moon, and India is till today the only country and first country successfully soft landed near the south pole of moon. And Aditya L1 is yet another successful story, and till today only 4 countries in the globe is having the satellite to study the sun, and we are having the Aditya L1. It has given huge data, 15 terabit data we have shared with the scientific community, and XPOSat is another success story. And a country, when we started 1963, we were truly 60 to 70 years behind advanced countries. From that, 10 places today, we are number 1 in the world. And Chandrayaan-1 finding water molecules along with USA, we are number 1. Mars Orbiter mission traveling 68 crore kilometers and capturing successfully. India is the first country and only country till today succeeded this mission in the first attempt. And PSLV placing 100 satellites. India is the first country which placed successfully more than 100 satellites through a single mission. Chandrayaan-2, of course, we could not soft land, but then we have placed a orbiter. Orbiter originally designed for 1 year, even after 6 years, successfully working. The best camera available in moon's orbit belongs to India. That is developed by Indians. I think let us give a big hand to Dr. Kiran Kumar sir, his team. Really, he has started his career in that, and today we are having such a fantastic camera. And optics, when we started, we had the 1 kilometer resolution cameras, but today, moon's orbit 32 centimeter, and RISAT, we have placed 28 centimeter resolution. We are world-class cameras we are building. And Chandrayaan-3, soft landing, first time near south pole of moon. S-200, solid propulsion. There was a time, whatever solid motor you make, everything blast. But today, just with 2 S-200, 207-ton propellant loaded solid motor, just 2 static tests, we boldly went for the first mission, and it was a grand successful mission. And cryogenic technology, this technology was denied to India, and thanks to those countries which denied the technology, and we could make 3 propulsion systems, and we are one among 6 countries. And not only that, in that development, we have made 3 world records. One of the world record is number 1, with 3 engines we have succeeded compared to other countries, 7 engines. And between engine test to flight, we have done in 28 months compared to the world record of 34 months. And a stage level hot test, 5,000 kg of explosive hydrogen has to be used. Generally, after moving the stage, people take 10 months time for doing lot of experiments, spending crores of money. And when Kiran Kumar sir was the chairman, as the project director, we approached him without any experiment, with only digital simulation, we will authorize the test so that we'll make a world record. I don't think anybody other than Kiran Kumar sir would have approved. He approved. Today we have made a world record. 34 days we have succeeded a stage heart test. And world record is only 68 days. This record cannot be simply broken by anybody else because no other person like Kiran Kumar sir is going to give such a clearance for doing this type of missions. And there are a lot of things, and we are targeting for at least 10 more places, #1 position in another 3 to 4 years. And global leadership, you know, the first satellite was launched in 1975, April 19, Aryabhatta. From that beginning, a lot of support came from other countries. Truly, if you ask, frankly, if you ask 50 years back, our knowledge on satellite and launch vehicle was just LKG level knowledge. From that, when Modi ji took over as the Prime Minister of India, we have built a satellite, a 1000 kg communication satellite, conceived, built and placed in orbit and donated for the South Asian country for their communication. Please see a country which was not having satellite technology. Today we are donating to other countries. We are building a G20 satellite for G20 countries. 70% role is going to be Indians, and other countries are going to contribute, and the data will be shared by all the G20 countries. And we, as a country, strongly believe it is not only our growth is important, the growth of global community is important, we also support other countries. And NISR was a successful story. And LUPAX, after Chandrayaan 3, we are collaborating with Japan. We are going to have the Chandrayaan 5 mission. And commercial missions, till today, 14 dedicated commercial missions we have accomplished, and 44 for 33 foreign satellites of 34 countries are lifted off. Out of that, almost 95% was done in last 10 years. And major achievements during 2025, a docking experiment, 2 spacecraft rotating with 28,400 kilometers per hour in space. We have successfully docked automatically, and India becoming one among 4 countries having that technology demonstrated. You know, the first launch vehicle mission was done in 1979. It was a partial successful mission. And the 100th launch vehicle mission was on 29th January this year. It was a grand successful mission, and we have written in the golden letters of Indian history that 100th launch was a perfect launch from India. And Axiom program, and we have sent till today 2 of our citizens to space. 1984, it was Rakesh Sharma, and this year, Subhashnu Shukla, I think he is with us. And thanks to Honorable Prime Minister of India, it was his vision. He wanted to send a person so that we'll get a lot of benefit. And today, Subhashnu Shukla is sent to space and brought back safely. And Indians have got major role in ensuring the success of that mission, too. And lot of experiments are carried out. And NASA's ISRO Synthetic Aperture Radar mission is a very historical mission. And today, the developed countries are really having great appreciation for the capability of India when we place successfully the satellite in the orbit. And we are already, the entire data calibration is completed. 100 years on 7th, we are going to have a conclave, and we are going to declare the satellite operational. All the data are outstanding data. Every 12 days, the Earth can be scanned, and it is going to be a highly useful satellite. And Gaganyaan program, we are currently working on our Gaganyaan program to take our human being, our citizen to the space and bring them back safely. And lot of activities are going on. In fact, I want to tell 8,000 tests are completed till today. 8,000 tests, almost 97% tests are successful, except small setbacks, and which we have fully understood. And we are going to have 3 uncrewed missions, followed by the first crewed mission targeted in 2027. And I don't have any doubt, it is a country's project. It is not only ISRO project, all the total countries working, the type of, the capability of the country. I am 100% sure it will be a grand successful mission in the first attempt itself. And Gaganyaan follow-on mission, there are a lot of missions which are in the pipeline. It is not only 1 crewed mission, there will be 2 crewed missions. And we are also building a space station. Honorable Prime Minister has given the direction and guideline, and we have got the, it is a 52-ton space station. This will be commissioned in space before 2035. And the first module, we have got the project approval. It is a 5-module construction. First module will be placed in orbit in 2028. And Chandrayaan 4 and Chandrayaan 5, we are working towards that mission. Chandrayaan 4 will be a sample return mission. Chandrayaan 5 will be a heavy lander mission. And Chandrayaan 4 for Chandrayaan follow-on missions. And by 2040, We have been given a direction by Honorable Prime Minister to take our citizens to the space, to moon, land safely, and bring them back safely. Towards that, lot of developmental activities are going on. One of the important things is the launcher development. 1980, when we succeeded at the first launch vehicle mission, we placed 35 kg satellite in the low Earth orbit. This rocket has to take 80,000 kg to low Earth orbit. That is the type of capability improvement, and we are working towards that, and lot of technology accomplishment has to take place. And we are working on a Venus orbiter mission, Mars lander mission, and for improving the payload capability of our vehicles, lot of new technology developments, including new propulsion, new miniaturized avionics, lot of developments are taking place. Reusable area, technology area is yet another important area. This alone I can talk 1 hour, but I am not going to venture into that. And lot of work is going on reusable technology as well as air-breathing technology development area. And advanced technologies, we have just initiated, our youngsters are working on the combined cycle engines, and electric propulsion is a success story. This finance year itself, we are going to have a launch with all electric propulsion, electric propulsion as the key propulsion system. In fact, compared to chemical propulsion, this gives almost 6 times higher performance. You can understand, for example, I will tell Chandrayaan-3 as a spacecraft out of 4,000 kg, 2,500 kg was propellant mass. If this type of systems are used, then the propellant mass will drastically come down. And then advanced technologies, we are working on lot of things, including quantum communication, nuclear thermal propulsion, in situ propellant utilization, radioisotope heater, lot of work is going on. Major research activities, this single slide is from 9,000 page document. A summary of 9,000 page is converted into a single slide. Very difficult to explain entire thing, but you can read lot of things. We are working on air breathing, reusable. On-orbit refueling is yet another important area. For example, the debris management is a very high challenge. We are working on debris management. For that, one is on-orbit refueling, so that number of satellite launches will come down. Also, moving the satellite to graveyards, docking experiments, atomic clock and TWTA is yet another important area. For example, atomic clock. Till today, we have indigenously made 2 atomic clocks, and both atomic clocks are working successfully in the flight, in the orbit. And whereas some of the imported atomic clocks, we have faced a problem, and today we are in the indigenization process. And microgravity experiments, robotic experiments, artificial intelligence, I think the work is going on in multiple directions. Thanks to Honorable Prime Minister of India, today, currently we are having 56 satellites in the orbit, serving the common man of this country. But the need is huge numbers. Huge numbers are the requirement. So we are targeting to make this number to 3 times in another 3 to 4 years. And so ISRO alone cannot work on this type of program. We have to build a vibrant space ecosystem in the country. The space sector reform is rolled out today. 10 years back, only 1 or 2 startup companies were there. Today, the in-space system, NCIL system is working closely under Department of Space. And then today we are having 330 startup companies. In fact, 2 startup companies have launched their tiny rockets, and they are working in a big way. A lot of people are working in a big way. And satellite data utilization, the companies are working in a big way. And our target is to move out the operational launches to private sector. And the first rocket coming from the private sector, the PSLV N1 rocket, is going to be launched this year. Space economy, in fact, when we started our program, our thinking was only to use the space data for common man of this country in multiple places. But today, we are working on the space economy. When we assessed, our share is hardly only 2%, and $8.4 billion only. And this number is going to be taken up to a level of 11% by 2047, and something around $130 billion. So we are working towards that. And launch vehicle production through the industries consortium, we have initiated the activities. And there are a lot of important activities are going on. For example, this year, we had for implementing the space vision, whatever given by Honorable Prime Minister, we have done a lot of things. We had a space meet, national space meet, 63 user departments, all state governments and UT, union territories, we have taken the requirement, 90 documents, each 200 to 250 page requirement documents have come out, and that is converted into a executive summary, and we are going to execute the entire activities in the coming years. And coming to the Space Vision 2047, Honorable Prime Minister has given a clear direction and role, and of course Gaganyaan program, and we have to improve the operational satellite capability to at least three times in 3 to 4 years. And he has given a clear guideline. In another 5 years, launch capability should increase 50 launches per year. And I can tell in this August audience, ISRO will meet that requirement. Why 50? It may be a little more than that. We are working towards that. For that, 2 more launch pads. Right now, we are having 2 launch pads, and 2 more launch pads are getting built. And we are targeting, when Prime Minister has given a target of minimum 50, we are working towards 60 launches per year. Then we are working on the next generation launcher for enhancing the capability from 35 kg 1980 to 80,000 kg in 2030 type of time frame, 2030, 35 type of time frame. India is going to have its own space station, as I told, and Chandrayaan missions are going to continue. And by 2040, we will have the Indian landing on moon by Indian launcher. And our Honorable Minister Jitendra Singh Ji used to make a very fantastic statement, which I liked. You know, when we are working towards the Viksit Bharat 2047, and I don't have any doubt India will become a developed country before we celebrate 100 years of independence under the visionary leadership of our Honorable Prime Minister Narendra Modi Ji. I don't have any doubt. And our minister used to make a statement, by 2040, Indian will land on moon with the Indian flag and declare that in a couple of years, India is going to become a developed country. This is what he used to make, which really I like the statement. And dear friends, a country which started with a humble beginning, with bicycle era, moving rocket parts in bicycle, moving satellite for some experiments in Bangalore. First Apple experiment, Apple satellite was moved in Bangalore for an experiment in bullock cart. From that bicycle era and bullock cart, we have come a long way, going to moon, Mars, and landing on Chandrayaan. And I can make in a single statement, by 2040, a country which started, at the time of starting, we were 70 years behind advanced countries. By 2040, we will be in par with any other spacefaring nation in terms of launcher capability, capability, satellite capability, application. Now, before I conclude, I have to share one of the very important mission, what is done a few days on 2nd. The CMS-03 satellite was successfully launched just on 2nd evening, which lifted the heaviest satellite, communication satellite, to GTO, 4,040 kg satellite. In fact, today, the satellite operations are going on, 3 firings are completed. The satellite is moving towards its final site, and we are extremely happy. The entire space team is so much happy to be here after that great successful mission. Probably you can see that launch video, 1 or 2 minutes. Let me locate the launch video.
So thank you, Narayanan, for that excellent overview and
Yes.
bringing 2047. Probably we'll move ahead.
I think video, what happened? Can you just click, sir? Only 1 minute, sir, this
Yeah.
video.
5, 4,
Yeah.
3, 2, 1, 0.
This was the launch, what happened on 2nd of this
S200
month.
motors ignited, plus 5 seconds. P1 tracking, lift off normal. P2 tracking.
Okay,
15
fine.
seconds.
So the satellite, the heaviest communication satellite is placed in the GTO. 13 years back, a
S200
similar
motors
satellite we have
separated.
to take to other countries, and we have to launch. Today, we are very happy that we had built the capability, and we have successfully placed in the orbit. Thank you. Jai Hind.
Thank you, Narayanan, for that excellent overview and what is ahead, what is lying ahead for till 2047. Now we move on to the next invited talk by John Paul, CEO of Misitech.
Good morning, everyone. At the outset, I would like to thank to get this opportunity and speak in front of you and share whatever small and infant stage ideas that have evolved through us to you. And also I'd like to thank the veterans who are sitting in the dais, scientists, innovators who have assembled today, distinguished colleagues who are also in pace with me in this journey. So my talk will be focused on the journey of engineering the extreme and highlighting the need and importance of high temperature composites. And as Sir was saying that we had started a very humble beginning, and yes, now we are at an epoch of time where we are not just followers, but we are also trying to lead in many areas, and probably high temperature composite is going to be one such area. So of course the first question comes at this juncture, why we are having this particular subject or why we are talking. As we see the spectrum of missions and programs that India is going to lead globally, it calls for materials, which becomes the basic foundational element of all these missions. And when you talk of extreme environment in terms of heat fluxes, temperatures, radiations, structural loads, vibrations, put together, the coupled effect of all these loads together, it demands products which can withstand very high temperatures. The temperature will start from 1200, 1300 degrees centigrade, and of course, in the coming missions, it will demand to operate beyond 2500 degrees centigrade. Then yes, the Gaganyaan mission is going to come, but in times to go, we will definitely like to have the manned mission in much more diverse, functional, and core to its performance oriented. So for that also, we need new materials. And as we are seeing that there is a very enhanced national demand which has risen, not only in the space domain or the space sector, but also similarly in defense, in the semiconductor domain, so we'll touch upon that. And if we have to say that we are going to lead in 2047, we are going to experience the beauty of Viksit Bharat, then we cannot be the followers. We have to lead. And we have to lead in very challenging materials, systems, products, and the engineering part of it. So the gamut of materials that is very challenging, and yes, it is not the whole map of it, but some of the very challenging materials that we have come across, and we feel that it is time that we become second to none in these materials. Because we already have made the foundation, we have made the first few steps, which is quite disruptive in nature. So we'll talk about the carbon-carbon composite, carbon-ceramic matrix composite, ceramic oxide composite, and of course, the future, which we are talking of the USTC, that is 2500 degrees centigrade, in that class of materials, that how we are going to step and lead in this area. So, just because it will run in time, but I'll just tell in very small way that we have seen in the aviation sector, especially the superalloys play a quite dominative role. Because the thermostructural, which is a combined effect of the thermal and the structural performance, that dictates the need of the material. And we see that within a range of 1200 or 1500 degrees centigrade, all the requirements are fulfilled. But whereas the type of missions that Honorable DOS was mentioning, it demands much, much more extreme environments where we have to withstand 2000 degree, 2500 degree centigrade without losing the performance of the material in terms of the structural capability. So you can see that even though the superalloys or the metals which has very high properties, when you consider it at room temperature or maybe up to 1000 degrees centigrade, but when we stretch the environment to very extreme temperatures, probably we are left with no other choice than these high temperature composite materials. So that have been our focus, and we cannot narrate all of its application, why it is very important. You can see the total circle of applications ranging in different domain, whether it is, we are talking in the aviation sector, each aircraft when it is taking on and touching down, each aircraft is stopped by a brake disc which is made out of this material. Every re-entry vehicle which will go outside the space and will come back, during the re-entry it has to face the thermal load and structural loads. For that you need this material. We are going to have to make India an epoch in this domain, especially in the strategic area. We need hot structures. Structures which are capable to withstand Mach number of more than 5 or 6 to up to 10, and in future, we are aiming to Mach number 20. So this is one segment. Then the other segment is the commercial segment, where we are talking of semicon industries, we are talking of photovoltaic industries. And if these industries have to play a very meaningful role, touching the economics of the domain, then we have to incorporate or replace the conventional materials like graphite with these high temperature composite materials. Now, as we see, as we have been interacting and we have got the mentoring of DOS, DRDO, and other scientific organizations, we are very focused of having the 4 use cases that we have to demonstrate our capability in the Indian context and within the Indian ecosystem. It will start with the thermal protection systems, then products related with the propulsion system, which is the nozzles. Of course, in the aviation sector, we'll be addressing the requirement first on the strategic aircraft and then on the commercial aircraft. And finally, even though it is not a high temperature composites, it is a spin-off of the high temperature material family that will come with dimensionally stable structure, which will play a very important role. And I'm very happy, and it is a very moment of pride for me that what happened to be one technology proposal given to Honorable Sri S. Kiran Kumar. At that time, he was the chairman, and it was just a draft of a technology proposal, and we proposed that because we was denied that technology. We was denied that technology, and we proposed it as an indigenous technology development, and we are very happy that we not only developed the technology at ISRO, and of course, when I moved out, we are trying to bring the value in the commercial market out of this technology, which is known as film boiling chemical vapor infiltration technology, and it is one of the technology which can make high temperature composites in a very faster way. And I can tell this August gathering now today that it is not that this ingenious technology is developed by us, but we are the first in the globe that we have this technology, and even many developed countries, they are now approaching us that they want to develop their products through us. So I will say that maybe I'm just a messenger to translate this message to you, but it is a total teamwork, and it was done only because of the mentorship and guidance of ISRO. And I was just a infant soldiers playing my role. That's it. So I'll not touch upon the technology, but I'll just tell 2 important points: the conventional technology and the technology that we are talking, which is film boiling CVI. If you see the circle, the red part, it represents the capability of our system. So in terms of the cycle time, we are talking of a process which is 10 times faster. A brake disc which is used in a commercial market, it takes 10 months of time. And the same brake disc we can manufacture within our technology with the same performance, properties, everything 1:1 if we do, we can manufacture it in 1 month. So that is the capability that has been developed within ISRO for the, because of the extensive research that we conducted for 10 to 15 years. Yeah. And finally, yes, of course, since I have stepped out of ISRO, now I cannot talk only about the technicalities. I have to talk also about the economics and how the nation is going to get benefited out of it. This is a call to all the scientists and innovators. Please join us, strengthen us. We have our weakness. And it is only through these concentrate efforts by all of you that we can address this market. Because everybody talks that India represents only 2%. But I think time has come, we all join hands, because there is a lot of opportunities that is there through which we can serve the nation. It is a market of $12 billion, and the immediate market that we are looking for in the service-operated market, it is $2.5 billion. And the coming financial year, we can add, next 2 to 3 years, we can address a market of $150 million. So, since I have been invited, I thank the organizers to give a fresh startup entrepreneur to represent this platform. And from this platform, I give a call to action for the following 4 major pillars. First of all, we have to look for the process sovereignty. If we are talking of Viksit Bharat, we cannot depend on somebody else. It should be indigenous, and it should be within the boundaries of the country, number 1. Number 2 is, time has come. Yes, of course, experimentation is important, but time has come. We depend on the digital twin, and we have to develop a qualification infrastructure for everything. Of course, ISRO is giving the mentorship to us, guiding. They are the guiding pillars for us, but we need other institutions also to help us in phasing out the qualification infrastructure. And finally, these materials and these products, it needs a very long-term action plan. So the strategic procurement plan has to be initiated now. And with this, let me conclude by saying a single sentence: let's engineer the extreme, make India the high temperature composites hub of the globe. Thank you so much. And yeah.
Thanks a lot, Paul, for showcasing the capabilities and also meeting the aggressive time target given to you. Thank you. We invite Ms. Jayanti Bhagata.
A very good morning. Thank you so much for having me here. Had it not been Rajarajan sir, I would not have made it over here. He's like, you're running around too much. Hey, stop, come over here, do something, share your thoughts. Enough of running around. Whatever you have achieved, whatever you're going to achieve, I think you should share it with the people here, and I'm so glad I could do that. What an incredible presentation it was, Dr. Narayanan, wasn't it? From where we started, how we progressed, and what we are going to achieve. It's been really, really thought-provoking, and I must say the journey that ISRO has undertaken is fantastic. And I'm a live example over here because I have worked with quite a lot of public sectors, and I must state this over here. Working with ISRO is quite different, They don't let you fail. They ensure that you succeed. So the entire team, and I'm telling this by experience, and Rajarajan sir, I remember, he used to come to our place, he used to sit with us and get us succeed. He used to say, no, we are not going to fail. If our vendors are going to fail, we are also going to fail. So that's the approach they carry. And I think that attitude is there with everyone in ISRO, and I've always seen that. Thank you so much. Here I am to present about more of a supply chain, what we are lacking, probably where we are. Because I come from, I'm a person who represents the Indian supply chain at a global level. And I know where the gaps are and what they talk about the Indian supply chain. There's so much more to discuss on the supply chain part. So I'm here to represent, that topic. And also, being a woman entrepreneur, first thing they say, you have to explain, you have to share your journey. So I'm just, I was given a target, you have to finish this entire presentation in 6 to 7 slides. I said, I'm going to try my best. So here I am. I'm not going to take much of time, but whatever time I'm spending with you all here, I really believe and want it to be very productive. So any questions, I'm always here. Please let me know. Just so that you know whom you're, who's talking over here, who I am, what's my background. Very, very interesting background. I was an architect and got into aerospace industry. Did quite a lot of, I must say, path-breaking deals, not just for the companies that I worked for, but for the country. I talked to the major global OEMs, tier ones, got them to invest in India, and this started back in 2003, 4. You know, when everyone was just even thinking of what is Make in India, we were already there, you know, we wanted to make in India back in 2000 and 2003, I'm talking about. So I did quite a lot of joint ventures for the country, got them to invest in India, and that's how my journey in the aerospace industry began. That's a quick background about myself. And I'm just going to quickly take you through what I have done so that you know more about me. I was the one who led the aerospace park in a tier 2 city. Back then, we were just still scratching the surface of the aerospace industry. There we are already establishing a private aerospace park, invited the back then we had our civil aviation minister, Praful Patel, who came, agreed to inaugurate this park. The whole idea of this park was that the raw material comes in and the finished product goes out of this aerospace park. So that's how we designed this, and we were successful in that. We launched that, and even today, if you see, a lot of aircraft parts, the commercial, be it defense, are all getting manufactured in that hub. I also brought in quite a lot of relationships, companies with Belgium, UK, you know, many European countries. You know, I was the one who talked to them and, you know, emphasized that India is a place that you need to invest in. Back then, you know, it was more of cost competitive. You know, I'm getting this product done at, say, $100, for example. I need to get it done at $60 in India. So that's how they looked at India. But today, I can see that complete difference where today we are talking about, you know, the capability, the capacity that India has. And everyone is like, no, cost is not the driving factor anymore. We need a reliable partner. We need skilled people over here. So it's slowly changing towards India being recognized more as, you know, on par with the other developed nations. So I'm so happy, and I have seen this journey happening. And of course, I brought in the largest Airbus deals, Boeing deals to the country. If at all today, you know, I don't think you'll be surprised, but the wing parts of A350 XWB, A320, A400M, all are getting manufactured in Bangalore. And those deals, I signed it. And I'm so proud. When we brought it over here, we were just in 2 ship sets, 3 ship sets per month. But today it's like almost 50, 20 ship sets of each programs. So that's the kind of journey we've had. And I also facilitate the global composite expert. And I'm so happy that I found John Paul, who completely took us through the composite. So I'm going to come to you for more business. So, you know, I facilitated this gathering back then, and you should see the young generation, the young engineers, eyes sparkling with so many questions. And I knew, you know, they are here in the right industry, they're doing the right thing. And I'm so glad to have done that. So after working for all the organizations and bringing them to more profitable companies, I thought it's time that I start my own venture. In 2015, I started my company. And you know, after that, it is like I was even more busier than how I was, and I was like totally on to more selling Indian capability. You know, the tables have turned. Earlier, I used to bring the technology back from those countries to India, and today I'm saying, no, we have the capability. You know, you take our technology, we will work together, we'll partner with you together, we'll, you know, co-work on programs. So that's the change that I have brought in. We set up our facility in USA. I chose to be closer to the manufacturers because of the accessibility and everything. And today I work with almost all aerospace companies in India. And I'm glad to have been associated with ISRO, all the public sectors. So I'm just going to quickly take you through on the supply chain required for space missions. Now, what is the lessons that we have learned from the global space agencies? And this I speak with my experience after talking to the people in NASA, the Japan space agencies, you know, when they share their a roadmap, you know, back then how it was and how we are structured now, I've picked up quite a lot of information from them, and I've just put this together for you all. Global space industry is crossing $1 trillion by 2040, yes. India is entering into a new space era. You can see that with the presentation that Dr. Narayanan gave, amazing. Where we are today it's just incredible. ISRO's mission successes are world recognition today. You know, gone are those days when in 2000s when I used to be in US, people used to not take us very seriously. And today, you know, they are telling me, you know, they have a launch on 2nd, and I'm like, okay, I didn't know about it. So that's the change that we have brought in. Private sector, startups, MSMEs are rising. Make in India the global space manufacturing hub is the opportunity right now for us. Now, why supply chain matters a lot in the space? Space mission means precision, reliability, and innovation. It goes without saying. And what we need is deep supplier networks needed across, okay? In materials and composites, of course, I've got the opportunity to go through what John Paul is developing, and I'm so glad we need more and more people coming forward to do that. Electronics and avionics, propulsion systems, testing and certification. Now, I would like to dwell upon more on the testing and certification. You know, even today, I think we are all so happy and proud when we say that, oh, I have received Airbus certification, I have received Boeing certification. You know, I want that to happen to our India. I have received HAL certification, I have received ISRO certification. You know, I want to tell that to the companies that I meet at a global platform. So testing and certification is very important, and I want ISRO to come up with the parameters, the processes defined, so that anybody, you know, any small time people can even get into manufacturing, and they say, okay, these are the testing processes, these are the certifications required, there I am in. So that is very important. And national capability is strategic autonomy and leadership. This is very, very important. You know, we should be self-sufficient. Our dependence on the global OEM manufacturers should be absolutely very, very minimal, and I think we are there, we are reaching towards there. And, you know, these are things that, you know, the global agencies have told me during my discussion with them. What have been their common success pillars is long-term vision programs. Now, if you're launching, now we have heard that we are going to be doing about 60 launches. You know, the amount of robust supply chain that we need is unimaginable. Only then we can achieve that 60 launches. So they always tell me, you know, Jayanti, you know, long-term vision plans are required. You know, we even create vision plans for the next 20 years. So that is very much important, and I'm sure we are on track with that. Government as an anchor customer. I think this we agree. Here also we are having our government as our anchor customer. Tiered supplier architecture. Now this is very, very important because I bring this experience working with both these large organizations where they have a tiered architecture structure in the sense. Now there is the OEM who gives the responsibility to the tier one saying, listen, this is my objective. Now these are the parameters. Now, you design, you build it, and then you have to deliver it to me. The tier one, what it does is in turn, they build tier two, tier three, and they handhold. So the entire pressure from the OEM is relieved so that the tier one, tier two, they undertake their responsibility. So that needs to be established. I think we should work towards that. I'm sure, sir, you agree to it. More and more players are coming into it, but if we can have that tiered structure in the supply chain, that would really help a lot of people. Funding grants and R&D programs, of course, we've had on day one, Prime Minister Modi announced about 1 lakh crore of funding and grants. We need something, you know, that is really, really encouraging. When I prepared this presentation, I was not aware that he's going to announce that, so we are very glad that he did announce it. Supplier mentoring and tech transfer, this is very, very important. So as and when, say, ISRO develops and achieves that technology, I think they must hand it over to the tier 1 or tier 2, and then get them to implement it. That way we will be able to accommodate the number of launches that we have. So that's also very important. And again, I lay emphasis on the strong quality and certification culture. And what India needs next in terms of priority and in terms of action. Supplier development, again, national tier 2 and 3 MSME programs. MSMEs are contributing to almost 30% of India's GDP. We must focus on the MSMEs because they are the backbone of our India's GDP. So as much as possible, the MSME needs to be developed. Testing labs, we're looking for shared labs, infra parks. Financing, of course, CapEx, working capital support. That's the main thing a lot of companies struggle with, is the working capital and the CapEx. Tech transfer, long-term demand, in terms of, companies coming and telling us these are the procurement visibility so that you can plan accordingly, so that you can cut short your long lead time, you can plan your procurements and all that. Of course, R&D, joint research hubs, labs, and scholarships. These are things that India should look at the next things. I'm sure they're already planning for it, but I really want to emphasize. A role of women-led organizations. We have to build India as a world's most reliable manufacturing hub. We are there. We are more of a participant, but we are achieving more. We would like to be seen as a leader in this, which I think we will definitely achieve with whatever presentation I have seen, and I'm so happy that we are on that path. Women-led MSMEs should be looked at more of mission partners, right? Lead in building composites, precision parts, assemblies, and technologies. We have to be driving innovation and include us. We have to build capability first and then look at capacity, strong certification culture, supply chain independence, no dependency on the foreign manufacturers. That's very, very important. And I would like to always say, diversity is not a strategic advantage. It's not a metric, like we say, okay, it's just a checkbox that I need to have a woman in this underrepresented group. No, it's more of a strategic advantage. We are more of a mission partners. So include the women entrepreneurs as more of a mission partners rather than a metric. Call to action, I would say, invest in supply chain strength, empower MSMEs and startups, build talent, R&D and pipelines, which we are already doing, create global export capability. So things should get exported from India. I really would love to see that. Enable and support women founders. There are so many women founders who are looking for support and encouragement. Please do that. We are not just entering the space economy, we are also shaping it. And having said about all this, what is JBI Aerospace doing?
Last 1 minute.
Yeah. What is JBI Aerospace doing? We are building a composite component manufacturing facility in Bangalore, in the outskirts of Bangalore. We will very much be working with all the public sectors in India, and we will definitely be contributing to them. And we are absolutely thankful to ISRO.
Yeah.
Thank you so much for having us here.
Thanks a lot, Jayanti. And you can see how an architect can change the architecture of space economy in the coming years. Thank you very much for bringing in that new perspective. Now I request Professor Sanjay Mittal, IIT Kanpur.
Thank you very much. It's an absolute privilege being here. So what I'm going to do in the next 10 minutes or so is share some of my excitement about the things that are going on in the space sector in India, and perhaps some of the things that we can look at. So space exploration, I mean, every child is now excited about it, but I just thought we'll go through some of the aspects of it. So one could explore through rockets, satellites, space stations, telescopes, and rovers. We can ask a lot of scientific questions, some being very mysterious. Is there life elsewhere? Space has something to do about national supremacy. We have seen how good we feel when ISRO has done so well. It leads to collaborations in the nation outside the nation. We can look at resources elsewhere. For example, people are talking about, how we can leverage the resources at Moon, perhaps at Mars. It also has some aspects which are common with, war preparedness. We can have unmanned space probes. There are some already in the space, so we can do interplanetary exploration. We have some Indian probes as well. If you want to do deep space exploration, that would actually be very critical in the coming few decades, then we would need novel propulsion system, and we already saw in the talk in the morning that we are looking at some of them, because there the power will become a big issue, and how we power these devices. India has done obviously remarkably well in space. We should be proud that we not only launch our own satellites, but we also run commercial ventures. And one of the USPs of our program has been the low cost. We've done things at a cost which others cannot even believe that we have done that, and I'll show you some examples of that. And this trend is going to help us a lot, because if you look at the cost of launching satellites, it's really come down. In the 50s, where we were talking about $1 million per kilogram, now we are talking about a few $1,000 or a few 500 kind of a dollar, and that's where our expertise would be very useful. So I'm going to say a little bit about how we can use technology, new ideas, which ISRO is already working on, to reduce our cost. So as you know, when we carry some payload to the outer space, or maybe even to something like orbit of the Moon, we are going to spend a lot of fuel in carrying it. We'll have to carry the fuel, and sometimes we also have to carry the oxidizers. So if we can replace the takeoff mass with something that we could collect on the way, so that's where the air-breathing engines can be very useful in making these missions lighter. I just wanted to draw your attention to one particular mission, which I actually show in my class, that how complex space missions are. So India had this Mangalyaan mission, the Mars orbiter mission, and what you will see is, when we need to go to the Delhi railway station to catch a train, we kind of time our arrival with the departure of the train, and you'll see the complexity here. So the launch vehicle was, fired on November 13th, and you can see the position of the Earth, and the Mars is, way, I'm sorry, I don't have a pointer here, but you can see it is to the extreme left of it. And then we did not have a heavy enough launch vehicle, so we used the gravitational pull of the Earth, and we put it in one orbit on 5th of November, and then we raised the orbit in a series of steps. So all this is controlled from Earth, and by that time Mars has moved, as you can see, and then we put this device in another orbit, which is now going around the Sun, not the Earth. So we time it with Mars, and finally, after about 300 days, we put the device into the orbit of the Mars. So there's really a lot of precision that is required. I mean, if I had to, go to Delhi railway station and catch the train within a fraction of a second, it would be such a challenge. So that should give you an idea. And to this, there are a lot of stochasticity. So there could be breeze, there could be solar winds, and we have the capability to do all that. So it is intellectually extremely challenging. And we saw this also on the currency note, that recognition. Just to let you know, this was the least expensive Mars mission ever. And probably one thing to notice is that the lift-off mass was of the order of 1,350 kilograms. And the payload that we carried is only about 13 kilograms, so 1% of the lift-off mass. So that's something you might want to keep in mind. So ISRO has been thinking about this two-stage orbit system, where we would take off almost like we usually do, but then the first stage is like a space shuttle. So there's a solid rocket booster, there's a liquid propellant, and we get the launch speed. And then somewhere when our speed is about Mach 4, then the scramjet, which is a supersonic combustion ramjet engine, I'll say a little bit more about it, that kicks in, and it would accelerate the vehicle to Mach 10. So when the propulsion system is the air-breathing engine, then actually we are just using the fuel and we don't need to use the oxygen, the oxidizer that we usually carry. So it would save us a lot of payload. It would give us some space for the payload. And then at about 80 to 100 kilometers, the second stage kicks in. And by that time, the first stage would come back to the Earth like a space shuttle, and we can reuse that. And then the second stage actually launches the satellite, and you see that picture on the left. So that is also deorbited after it launches the satellite, and it is safely recovered. And therefore, we have a mission which has a very low cost. So these are the experiences that would actually make us very, very economically viable. So just wanted to tell you the heart of the technology here, the scramjet engines. So I'm sure you have all, we had Diwali very recently, so you've seen candles when there's a huge breeze, these candles go off. So now imagine that I had an engine, and I was, this engine was going at supersonic speeds, and there's of course a flame that needs to burn the fuel. And you would worry that if the airplane is going so quick, or the launch vehicle is going so quick, then why doesn't the flame go off? So that's a special technology where you need to stabilize the flame. So normally what is done is you slow the flow down. So when the aircraft is moving at a high speed, then the air comes in, and there's a device called an air intake. You slow the air down so that it comes to a low enough speed that you can burn the fuel in it and you can stabilize the flame. But it turns out that when you go to speeds like Mach 10, then you cannot slow it down enough because that would lead to very high temperatures, the combustion is inefficient. So you need to actually burn the fuel at supersonic speeds. And that's a technology that many, many countries are grappling with. Fortunately, India took a lead some time ago, and we are doing quite well. So I've listed here some of the successful programs that have combustion, the supersonic combustion. So Russia being one, US, of course, has had many programs. Australia has had some standalone programs and collaborations with US. Brazil and China have had some success. And India, of course, there are two organizations that have been looking at it. And I'm very happy to tell you that we have a very successful scramjet program, and therefore we are on track for this technology. So what does a scramjet engine usually do? So on the underbelly of the vehicle, you would take air inside, and that's shown on the left picture, top picture, and there's a small cartoon at the bottom. So you slow the air down through a series of shocks. So usually these are 2 or 3 ramps. So you get these oblique shocks. You slow the flow down, and then you put them in some kind of a throat through them, and then you inject fuel in them, and it can give you energy, and you expand the jet, and that's how you produce the thrust. And this is common in fighter aircrafts as well. In fact, the Concorde, the supersonic commercial aircraft, also had air intakes where you would have to flow down. So there are some pictures of aircrafts. So there's a synergy between working on these technologies which can feed both the space industry and the aeronautical industry. So the idea of an air intake is that you take the flow in and you slow it down so that the efficiency is high, and you push this air to the engine. In this case, it's a combustor, so that the flow is quite uniform. There's not much distortion, otherwise we get loss of efficiencies. Typically what is done is, I have shown a cartoon of a ramjet engine where the air rams in. There are no moving parts in this. There's no turbine. There's no compressor. So air comes in. It slows down. You inject the flow after the afterbody, and then you have combustion. Then there's a nozzle which expands this flow, and you produce thrust. So here is what really happens. So the combustor has high pressure in it because it's of course, there's a lot of energy being released there. And of course, there's atmospheric pressure outside. So you need to somehow stabilize this flow. If the pressure inside is too much, you can imagine this flow is going to be squirted out upstream, and this thing won't work.
2 more minutes.
Yes, I'll take that. So we use these devices to actually position the shocks and engineer the flow so that we get high efficiency and we get good stable characteristics. So here are some simulations for these model air intakes. So this is a double ramp intake, And if you do calculations with a low fidelity model where you neglect viscosity, then as you see, as the pressure increases, so there's a pressure ratio on the upstream and downstream, the shocks move to the throat, and then at about, you can get a pressure ratio of about 32. But if you increase if you take a viscous model, which is really a more real model, then you find that as the pressure increases, the pressure ratio, you can get some very strange instabilities, and they are very detrimental to the structure. So we need to first simulate them so that we don't push the real engine into these regimes. So I'm just going to show you some animations and be done with it. So the top picture is an engine which is operating well, so where the throat has kind of a shock there and it's oscillating. And then at a pressure ratio of about 28, it unstarts and you get these shock systems going back and forth. So this is bad. We don't want that. Even more worse is things like the buzz instability, where your flow, there's a shock boundary layer interaction, and the name itself suggests you will get this high frequency instability, bzzz, that kind of a thing. Okay? And you can get low level instabilities where the net mass flow rate is positive, and you can get the big buzz where you have instabilities which are so strong, you can actually have a net negative mass flow rate, so the flow would be coming out. And to make it more complicated, you could have instability where you have a little buzz followed by a big buzz, and so on. So we need to set up tools, we need to set up computations, experiments to figure these out so that we can have reliable systems. So I'm going to end here. There are some concluding remarks which you can read. Thank you very much for your time.
Thank you, Professor, for bringing out the impact of simulation and how it needs to be an essential part of development. Thank you very much. And I wish to thank all the presenters for the excellent job they have done and in showcasing to us what is ahead till 2047. Thank you very much.
Sir, may I request any concluding remarks from you for this session?
No, I thought I already did that.
So with this, we are completing the first segment of this thematic session. And may I request Secretary MOES, Dr. M. Ravichandran, to come on the stage and felicitate our Honorable Session Chair, Keynote Speaker, and Thematic Committee Chair for their inspiring addresses. Thank you, sir. May I request for a group photo? Now we move to the another highlight of the today's session, which is the panel discussion on development of Indian space ecosystem. This panel brings together thought leaders from government, industry, and policy makers to discuss how new space is evolving space-based critical technologies. Our moderator for this session is Sri Shantanu Bhattavadekar, Senior Advisor NSIL, and the panelists are Sri Raj Rajan, the Balaji, Rajiv Jyoti, and Praneeth Mehta. I request all of them to come on the dais. So we begin the panel discussion, and I request Sri Shantanu Bhattavadekar to moderate this session, sir. Over to you, sir.
Good afternoon, everyone. Respected session chair, Kiran Kumar sir, Dr. Narayan, Secretary, Department of Space, secretaries of different ministries. I am honored to welcome all the distinguished panelists on the dais and all the esteemed delegates present here to this panel discussion on the theme and development of Indian space ecosystem for space exploration, applications, and sustained human space missions while evolving space-based critical technologies for societal applications. To begin with, it is my pleasant duty to briefly introduce the distinguished panel here. So we have with us Shri A. Rajarajan. He is a distinguished scientist and director of Vikram Sarabhai Space Center. He is an engineer par excellence and a specialist in design and development of launch vehicles, launch complex configuration, solid motor production, and the spacecraft composite systems, including the carbon-carbon composites, where he made India a significant player in this niche area. We have also Shri Rajiv Jyoti. He is a distinguished scientist and director at InSpace. He is a renowned expert in design and development of indigenous space antenna systems and microwave payload technologies. Shri Rajiv has steered the development of India's first 3 satellite constellation of X-band radar satellites, and he has developed several novel antenna systems like multiple beam antennas, gridded antennas, multi-shared aperture antennas for more than 25 to 30 communication and navigation satellites as well. Then we have Shri Balaji N. He is General Manager, Aerospace Division of Hindustan Aeronautics Limited. He has an illustrious career in industry with a stint in marketing, projects, customer services, and production. Shri Balaji is significantly contributing in the Gaganyaan program and human spaceflight program of India, as well as he is currently steering the end-to-end production of PSLV and SSLV at HAL. Then we have Shri Praneeth Mehta, a very young entrepreneur. He is a co-founder and vice president of business development at Galaxy Space. Besides strategy and satellite business operations. He is currently steering the development of world's first constellation of multi-sensor imaging satellite. So Shri Pranith is very passionate about transforming bold ideas into impactful solutions, bridging the gap between technology and real-world applications. So, of course, before I proceed further with the co-panelists and for the discussion, I would just like to, set a brief context. Of course, you have already heard the very inspiring speech from Dr. Narayanan, and I think he has already set the context. What I'm going to speak is just abstract of that, but just to set the context of the panel discussion, I will do my duty. So as you already know, the space technology and applications are the key drivers for bringing the social and economic transformation in many ways, by studying the planet Earth in totality for sustainable development, accelerating the development, facilitating connectivity, increasing the efficiency of governance, improving quality of life, and all these things, thereby shape the country's economy and the prosperity. And you already seen in the slides the exciting journey of Indian space program, during the last 6 decades, which is truly inspirational in building indigenous technologies, be it launch vehicle or satellites or the various innovative applications for the national imperatives as well as for the betterment of humanity. So certainly the Indian space program has become the symbol of country's technological prowess, which has been exemplified through various technology missions. And today, India is a significant player in the commercial market as well. And, as our session chair also told, that today there is no, ministry, no department where, we are not, with the space technology as a relevance, we are always there. Be it a fisherman, be a farmer, an administrator, or policymaker, the space technology plays an important role for each one of them. And several milestones, like the Mars Orbiter mission or Chandrayaan-3, the AstroSat mission or the Aditya L1 mission, they all have been recognized not only for the technology prowess of the country, but also for its economical approach in the space exploration. And I think this economical approach, of course, comes through the optimized designs, how the ISRO makes, and also through the culture of frugal innovation, which is inbuilt in the ISRO's culture. But of course, as we are seeing since past few years, the global landscape of space activities, is very dynamic. We are witnessing the emergence of private players revolutionizing their space activities by bringing, cutting down the cost, cutting down the turnaround time, and bringing a lot of innovation and advanced technologies and contributing to global space economy. So thereby in India also, of course, now with the forward-looking space sector reforms and the policies in place, we are also seeing a very more inclusive space ecosystem is rapidly evolving in India as well, which is aligning well with the global scenario, technology trends, and also the sentiments of the industry and aspirations of the government. And 2020 to 25, when the space sector reforms were announced and policies were announced in 23, it's hardly a time of 3 to 4 years. But in such a short time also, we have seen that the new space ecosystem, which is rapidly evolving, is started showing its results. We are witnessing significant momentum in the number of startups. We had earlier some single-digit startups, and now we have something like 300 plus startups in the space ecosystems. The traditional vendors for the ISRO and the MSMEs, they are diversifying and climbing the value chain. We have the industry consortiums now producing the PSLV and SSLV, and there are many other private vendors and entrepreneurs who are now designing the state-of-the-art EO constellations and also delivering information products. Of course, ISRO and IN-SPACe are giving a lot of momentum to this entire ecosystem by taking several promotional and hand-holding measures and nurturing them. So what we are seeing is, you already seen about the new trajectory or the program or roadmap since 2047, what ISRO has now. And to realize this, of course, we need to nurture the deep tech collaboration in building core capabilities in additive manufacturing, space robotics, reusable launch vehicles, deployable structures, and many more such technologies. But our main aim is for the new ecosystem is that we would like to take along the industry, the academia together while leveraging the capabilities of the National Space Agency. And at this very same venue in the Bharat Mandapam, in August, we had a national meet, and wherein also we have emphasized on the need of whole of government and whole of nation approach, that we are together as a collective effort to build the space infrastructure. So I just conclude with a statement of our Honorable Prime Minister, what he made, I quote, that when the strength of government space institutions and the passion of India's private sector will meet, not even the sky will be the limit. So truly inspired by his vision, we are embarking on this new exciting journey of the new space enterprise. So thank you very much. So just to start with the panel discussion, I would request each of the panelists, I'll give some perspective. Maybe you can give your views in 2 to 3 minutes time on the perspective which I put to you. And then later on we can have the question answer sessions with the panelists, and then of course the floor will be open for the audience. To start with, I invite Shri A. Rajarajan. Sir, please elucidate the gathering on the complexities and the challenges of this India's Space Vision 2047, what just now Dr. Narayan presented, including the development of essential technologies, and what is our readiness levels?
Thank you, Shantanu. See, basically, now the Vikasit Bharat, we all know, you can't simply take it as a slogan. So what we have to look at is, we have to start measuring our aspiration, where we are, especially in the space domain. So if you look at it, we have to accept for a developed nation, space technology is not only take care of some metrics like what is the commercial aspect, but it also shapes the national security, the competitiveness, and as a whole, as a culture, as we go, what is our confidence levels in our beliefs. And we also know space segment talks about a very high level of razor-sharp human problem solving capability. And every materials, every technology that gets tested and done, the complexities, the small things adds up and becomes a complex solution, and that's what we call it as rocket technology. And we know in space we have to experience vacuum, extreme temperatures, intense radiations, and actually there's no real-time corrections possible. You have to do it. So a single small mismatch in the thermal, a minor vibration mode, small things can create minor to major problems. So these challenges calls for deep capacities in materials, proportions, thermal systems, guidance, control, manufacturing precision, and the mission planning. So this is what we are now looking at. And they demand teams that blend science, engineering, disciplined execution, and the capability to execute multidisciplinary activities in a team. And that's what we called for. And it is high time that we start assembly in various areas. So we already shown that we can take care of, navigate interplanetary missions by going to Mars and Moon, all those aspects. The lunar landing, the cost effective. So that is a phase. And we also looked at how societal application can be done. Now comes the second phase, which is actually harder. This is going to be tough. The hypersonic flight, the reusable launch systems, and in-orbit refueling, as our beloved chairman already pointed out. The human space flight, its safety, and some of the manufacturing capability, including composite and advanced additive manufacturing, that can go into making a very compact and complex shapes, withstanding very high temperatures. So this is where an AI-driven design which is going to come in vogue now, and a quality culture. We basically in India have to develop a quality culture. That's what will take us to the second phase of the level. And the Viksit Bharat in space demands sovereignty of know-how and the courage to innovate, and where the world has not yet walked. That is the path we have to choose and go ahead. I also see we should not see, next generation should not see space only as a sector for scientists alone. It is actually a commercial activity, it has a national mission, and it has definitely an integrated growth involved in this. And that's what we should be able to. I think the policymakers, the entrepreneurs, we have to create a lot of entrepreneurs in here, and with skilled sets that you have to bring in this kind of domain. And that will also make the Viksit Bharat achievable and should be definitely on. We are on that path. I hope within the next 10 years we will be going to see a remarkable improvement in this. I hope everybody will be joining this bandwagon. Thank you.
Thank you, Rajan sir. Now I just invite Shri Rajiv Jyoti. Basically, sir, you have seen the rapidly evolving industry-friendly environment now. So I would like to know what are the various initiatives taken so far towards the ease of business and the future policies and initiatives which are on the anvil to further enhance the growth of private sector.
Okay, yeah. Thank you, Shantanu. I think before I respond to your question, I want to say here that you have seen that ISRO has been the architect of the whole space India's remarkable journey. And it's not only recognized in India as a space legacy, but also globally recognized organization, and we're among the few space-faring nations. And way back in 2020, the space reforms happened, and that one bold step which was taken by our Honorable Prime Minister of the government, and then one new chapter started, that is called InSpace. Let me tell you why I am here. The InSpace is an Indian National Space Promotion Authorization Center, which comes under Department of Space. So this is a new organization which was created 2.5 years back. And this organization is basically a single window interface for the industry. And the why industry? Because at that point of space reforms, the idea was that though we are doing, ISRO has made the dent in the space journey and made a point, but then still our space economy, as the Secretary Department of Space also mentioned in one of the slides, that the global space economy, we still have only 2% share. How to increase that? How to increase the more participation for the private companies as a standalone, owning the business of space activities, not that they are becoming only the supporting role to ISRO. So towards that, the InSpace which was created, I am the Director Technical, and we are taking care of, we have 4 major roles right now. One is we are enabler, we are facilitator, we are promoter, and we are also authorizer as a regulator of the space segment. So we, as now, Shantanu, as you said, that what are the various policies, we have brought out ease of doing business with the various government approvals. We have created a one interface mechanism, which is also norms and our guidelines, which are there with the consultation of an Indian industry, is available on the website. Anybody who wants to start a space activity, we are sending the space objects into the space. You have to follow those guidelines, and authorization has to be given by the InSpace. And then we also have a role of promotion, where we, knowing that space is a very highly intensive R&D and also risky business. So needs a lot of technology, needs to know the finances, needs to know the demand, and needs to know have a skilled manpower. So for making sure that our companies which are going to have going to start commission their activities over space, so that's our role, and we have come out with various policies. And there we are also taking the support of ISRO in terms of mentoring, also wherever the facilities are available, because those facilities which are there, if any company has to develop those facilities first and then start the activities, it will be a long gestation period time. And we also have created our own in-space technical centers in Ahmedabad. We are going to talking about various other, even for the, this is for the only the development, and also for the manufacturing, we are coming with the manufacturing clusters, incubation centers. And just I want to end here saying that now over the years, when we started this 2022, there were a handful of startups, and we had less than 10 companies who were registered with us. Today we have more than 350 companies who are registered as a space as startups, and they are actively participating and taking all the advantage of what InSpace is showcasing to them. And our major role is to find the gaps. Where are the interventions which is required for the government, and and then accordingly we create the policies for enabling them. Thank you.
Thank you, Dr. Rajiv. Of course, now I'll call upon Shri Balaji, basically to dwell on the growth of Indian industries in the space sector. You have very long association with the Indian space program, and also what are the future avenues of technology development in the industry, and how you see, position of the industry supporting the future ambitious missions of India.
Thank you. Good afternoon, everyone. First of all, HAL's association, if I put it, it has been in the journey with ISRO, has spanned for more than 5 decades, and which involved supporting ISRO in producing hardwares for PSLV, for their GSLV rockets, LV-M3 rockets, besides hardwares for the satellites. And not only this, even for the missions which are not only for making hardware, even for Mangalyaan, Gaganyaan, and Chandrayaan missions, we have supported ISRO. Looking forward, already there is we have reached a stage where inflection is already underway, and all of you know that SSLV technology has been is underway for transfer to HAL with definitely support of NSIL and InSpace, who had what you call promoted this activity of transfer of technology to the industry, and will be very soon building this rocket. Maybe the training is now started, and maybe in 1 year or 1.5 years time, there will be a rocket under license of ISRO, which will be flown by HAL. And this, I can tell you, it's not possible only with HAL. We are going to use the ecosystem which is already developed by ISRO, which will be utilized for producing this rocket. And not only this, there will be a lot of opportunities coming forward, where HAL will be a major integrator and not just manufacturer of the hardware. We will try and see how we can, involve the supply chain and see that activities which we have gained experience and expertise, how to transfer it to the industry, and we do a quality control activity rather than doing everything in-house. It's not possible for us if we have to be a major player in the space. And I'm sure with the experienced industry, with the MSME which is there to fully support us, and of course with the involvement of big players, I am sure we will be able to deliver the goods for the Indian space industry. Thank you.
Thank you, Balaji. Of course, now I'll move to a very young entrepreneur sitting here, Mr. Praneeth Mehta. So as a young entrepreneur, I just request you to share your views on the growth of the private sector, globally, and particularly in India now, with the, space sector reforms and policies in place. And what are the challenges faced by the entrepreneurs and the startups in terms of either policies, the opportunities, the developmental cycle, and the return of investment Because space is a very capital-intensive business.
Thank you so much, sir, and good afternoon to everybody present here. I am Pranit, one of the co-founders of GalaxEye. At the outset, you're probably wondering what a person like me is doing in such an esteemed gathering here. So, I have not even crossed 30. Building GalaxEye gets me the opportunity here, and in this audience, I am probably representing the eye of the STEC 2025, right? Representing the innovators and the startup ecosystem. Speaking of what GalaxEye does and coming to how the private ecosystem has evolved, right? Traditionally, if you look at the whole ecosystem more than 10 years back, we've seen the private ecosystem to be more of vendors to the larger space players. And if you look at how ISRO has evolved over the last multiple decades, it has built an industry around itself. And that is what we've been calling the space ecosystem. Over the last 10 years globally, and more so to be specific in India, private players have emerged as problem solvers. We are no longer entities that are awaiting tenders and bidding for opportunities and just being manufacturing partners. We've now evolved to build our own technologies. We've now evolved to build global first capabilities. And that all thanks to all of the space reforms we've seen in the last 5 years, right? Since 2020, like we've heard now, multiple reforms have come in year on year. Probably one of the fastest sectors to see such rapid reforms. Every year we see something new coming up. All of us are learning, right? Internally we always talk about this saying the policymakers are learning, the leadership of the country is learning, the startups are learning, the enablers are learning, and the users are learning. Everybody is learning in the ecosystem, and I think that is what is helping us move extremely fast and be very agile. At GalaxEye, we are solving one piece of the puzzle, and what we're doing is putting together the world's first and only sync-fused Optosar satellite. So it is an imaging technology where we put an optical payload and the synthetic aperture radar on the same platform. Now the ambitious part of it is nobody in the world has proven it before. Why are we doing it? Is one, we've identified a very fundamental problem of consistent imaging that only a country like India faces because of our cloud cover. Our counterparts in the West don't see so much cloud and they're not so worried about consistency, but we are, which is why we took so many advancements, which is why missions like NISAR came up. How did we get the courage to be doing like this? All thanks to the ecosystem present here, all thanks to the mentorship that we've received over the last 5 years. As graduates from IIT Madras, we had the right network and community to be part of, and with efforts being pushed from InSpace, NSIL, and ISRO, and at various levels, right? We've seen a lot of support and push from as simple as small grant schemes to very large projects that are being funded by the government, like the RDI that was announced at this very event. So I think challenges keep going, and we're all here facing all of those, so that's a never-ending problem, but very excited to see how this is shaping in the last 5 years and looking forward to this.
Thank you. Pranit, good to see smile on your face. So I'll just put few questions to the panelists now. May not be in the order of sitting, it can be random. So maybe I would like to start with Raju Jyoti. I know, of course, the kind of demands are coming now. So the end-to-end production of either talk about launch vehicles or the satellites by industries, of course, very much essential to meet these demands. But do you really think, because in the space business, before you build the launch vehicles and the satellites, you really need to know the volume and the demand. So do you really think, being in space, whether your current strategies, the policies and the processes are adequate enough, to accurately assess these demands and also the feasible models for productionization?
Yeah, I think this is the burning problem, that where is the demand? But the answer comes from that what he mentioned about that the demand which he has already seen, that there is a need of sensor which requires to take care of cloud cover. So now similarly, out of 300 companies who are startups, more than 350, nearly 350 companies, just I want to give you a landscape of that. There are 3 companies who are working on right now on a small satellite launch vehicle development. So the Skyroot is one of them, and Agnikul is one of them, and now HAL is also taken the technology transfer from ISRO, and they are going to do. So there is a demand that of the small satellite to be launched and launch also or launch on demand. So that capacity is to getting built up, and the technology transfer, if at all it is required from ISRO, that InSpace is facilitating for such activities. Similarly, for the demand which is not being envisaged by these companies, what we do is we generate the white paper, we understand the gap, like the one which we did 2.5 years back was the data, what type of data application, because which goes into the application to the common citizen. So what type of data is currently on demand? So we aggregated that demand and gave the brought a policy in which we were able to get a PPP model through Earth observation satellite development. So where we said that the constellation of 12 satellites, we generated the specification of those, and we told them this is the requirement. That requirement also was discussed with various users in the government and to the private sector, because there was a lot of data which is being now getting from the foreign sources will be start getting from this sovereign satellite constellation. And after 3 to 4 years, so this is the way we are bringing the demand of the users putting to the companies through PPP model. And many such things are on the pipeline which we are taking care. And also, we are also seeing that there is a demand on the ground stations as a satellite, ground station as a services, because right now all the ground stations which are existing today in the country belongs to ISRO. And they are available as on the best effort basis based on the demand, but then ISRO load also is increasing. So now we have generated a paper where we are saying that now this satellite ground station as a services should be generated a new business. So, and one more example I want to give you, which we already announced opportunity for satellite bus as a service, because all those companies who are making payloads like what he mentioned, they are good for making payload. But where is the bus, satellite bus, which is going to be totally a game changer for it? It is a totally multidisciplinary system which has to be learned in a different way. So we have announced announcement of opportunity where saying that anybody who will make the bus based on the specification which is benchmarked with the global standards, and those once it is available, then they will be giving the services to the payload companies who can host their payloads, and then they can be giving the services to the ground, to the common, for the commercial application, for the scientific studies, even for the educational studies. So these are the various models which we are bringing it to the companies. And the technology transfer which you mentioned, and you are talking about the other these things, so that also is happening. Yeah. Okay. Yeah, I think that's what maybe later we'll cover more.
So maybe I'll now also once again move to Praneeth, because you already started explaining about your multi-sensor satellite which has optical and SAR, and going to be the world's first constellation, probably known as Drishti mission. So the only idea was basically to eliminate the the requirements during the cloud cover, or you had some other aspiration behind this mission, and also how you really see the AI infusion in delivering such imagery intelligence in future.
So we didn't start building this because we wanted to do something very fascinating out of a research paper, right? And that's something that we're always very keen on. Let's pick a user problem and solve for that problem. And the problem that we identified was consistent imaging. So started by 5 founders. One of us used to work in a large conglomerate where he was working with satellite imagery, trying to identify damage due to a forest fire. And subsequently another problem statement in looking at disaster damage assessment and so on. Across these 2 particular problem statements at least, the common problem we identified was the lack of imagery when you need it. In case of a forest fire, if you want to assess damage right when the fire is happening, a traditional optical image will not give you an image of the ground. It will only give you smoke. You look at a flood, you look at a cyclone, you will only see clouds. You are not going to see the damage that has happened on ground. Right? These are problems that span across sectors, right? Most affected being critical sectors like defense, agriculture and allied sectors because of the monsoons and disasters. Which is why the world started moving to the radar-based imaging spectrum, where we started utilizing SAR data a lot more than we've ever seen before. Now with SAR, we at least internally often joke about it. There's a reason why radiologists as a profession exists, right? Otherwise, all of us sitting here could be experts in X-rays and CT scans. SAR is an equivalent of that. Microwave imaging gives you data sets that are complex to interpret, and you need specialized skill set. There are very few people in the country and the world for that matter who can analyze SAR data sets. So if you look at it, one sensor that has been available is intuitive but not available, and the other has been available but not intuitive. Naturally, somebody had to bring it together. People have tried doing it at various levels of software, but it has its own challenges because these two satellites capture at different resolution, different perspectives, different timestamps, and it's okay for very basic mapping applications. But when you want to monitor change, when you want to quantify that change, it is not very accurate. So we decided to solve that problem at core, which is why we call it sync fusion, where we're not just fusing two data sets, but we're synchronizing two sensors and then fusing the data sets. So that's how this evolved, and AI has a major role to play. So our fusion algorithm is AI-backed, number one. Number two, one of the very cutting-edge things that we're working on is building our own generative AI model. If you look at the Silicon Valley, everybody's talking of generative AI. We are bringing generative AI to space by saying that with a foundation model trained on our sync-fused OptoSAR data sets, we will be able to generate optical data out of SAR data, right? That's a very ambitious problem statement. Again, this is something that has been proven in the non-space domains very, very well. Generative AI images we've all seen with ChatGPTs and Geminis of the world. We are going to be building that for SAR and optical data sets. So as users, we never need to worry about hearing an excuse that, sorry, I had clouds, I can't capture an image. Right?
Okay,
That's what we want to
Thank you, Pranith, and giving good analogy between the radiologist and micro data analysis. I will just come to Rajarajan, sir. I say that India would acquire its full strength in the space sector, or you can call the aerospace sector, when we can build our own, and manufacture our own material, the components, the chips or alloys. We have such a big space vision 2047 in front of us. So what are the major factors, that will drive the future development of the composites or structures and alloys in future?
Okay, I'll try to answer in some entirely different perspective. Today, people call AI technology. Just look at the space infrastructure, the satellites that's been put in space. It's giving service. It's nothing but a smart item. It can be called AI. If you are not commanding anything, it continues to give service, right? You're all taking the TV, communication, everything taken for granted. It is providing the service, so it's supposed to, you can call it as an AI. Now, going to the next level, as your question asked about the materials, definitely India should have the capability to have its own materials, advanced materials, chips, semiconductor, all cutting-edge technologies. Here is where we have to leverage the AI, the capability that we have inbuilt as a civilization. Indian civilization is very good in mathematics, and we have to civilization. You would have heard of ChatGPT, and you know how many people knows about Alloy GPT. That is one big powerful tool. The additive manufacturing capability has come. We started putting not additive simply for manufacturing. We don't do that. We try to develop alloys. That is, we know the characteristics of each and every element. How do we combine that, and what kind of material it is going to give? So just try to see what is my requirement, and then take it back and develop. Similarly, we should take use of the technology that's already available, reduce the investment in cost, and try to put the advanced requirement. What is my requirement? Accordingly, you develop the material, And that is definitely possible. We are doing many innovation in developing new alloys, new chips, which is definitely required in the coming days, both in commercial aspects, the semiconductor aspects, to take care of the thermal, heat, thinner material, and the fatigueness due to thermal in semiconductor, around 153 nano, whatever we call. So how do we do it? Accordingly we have to do. And this can be leveraged to make some very sophisticated machineries also, so that it can be used to produce in a cost-effective solution. And that's what we are looking at.
Thank you, sir. Maybe I just go to Mr. Balaji now, and probably I'm asking this question in anticipation and with positive hope from the other private entrepreneurs. You know, HAL has built so much capital-intensive facilities. What is the take, whether any private industry or the startups can really approach HAL for utilizing these facilities, or it is only being used by HAL for?
No, now if you see our facilities, we are, it is getting utilized for private industry also. And not in aerospace in particular, even for the defense platforms, wherever for Navy, Air Force, there are a lot of private industries who are supporting these platforms. And for their process requirements, for their precision manufacturing requirements, they come to us and we support them. And we do not have any what you call inhibitions that way, that we will only cater to one part of the industry and another we will not this thing. There is a process. We have a registration process available in our portal, and any MSME, in fact, there are almost 150 to 200 companies which have registered, and they are getting work from us, and we are taking the support for a lot of activities in aerospace as well as in other HAL platforms, whether it is fixed wing, rotary wing, or other any platforms which we are developing. And that way, even for HAL, for ISRO facilities also, there are what you call channels available. You have InSpace now, which is nicely supporting. In fact, the way they are promoting the industry, supporting them, hand-holding them to use ISRO facilities or other available facilities in the country, I think only people have to come forward and take this what you call help. A lot of work is being done, and I really compliment. In fact, for that matter, if you say SSLV, the way it was tendered, and such a level playing field was given to the industry, and it is, I always repeat every time, that it is sad that industry people who made a lot of noise about privatization and things like that, unfortunately they did not participate in this particular tender, and hardly 2 public sector undertakings were there, and 1 private industry, quite big, came forward. And that's what I tell. There are a lot of big companies, big private companies, I will not name. They have to come up with a big heart. You know, everyone wants, nobody wants a share in risk. Nobody wants a share in infrastructure. Everyone wants share in revenue. Now that is a very sad balance we are seeing, and it's a very, it's a matter of concern, I will tell. Even big companies are coming to us and asking for rhetoric work, hardware manufacturing. There are a lot of companies. In fact, if I float a tender, there will be so many companies who can do that. We have done it. Now we feel that this should be supported by MSMEs. But big players who have to, big private players, I am telling. Public sector, okay, we have our own procedures and systems and all. Big private companies who are toing that every time telling that things have to be privatized, they have to take risk. They have to invest in design. They have to invest in infrastructure. If they don't do that, what example you are going to create for the MSMEs, for the small players? Small players, I understand. They need financial support. They need support of, and it is being done. InSpace is doing I'm thinking a huge service by pulling them, encouraging them, and bringing them to the mainstream. But private industries have to come forward. Big private companies.
Of course, we are a little short of time, but still I will go for, I'll extend the question what Balaji was asking to Mr. Rajiv. Being in InSpace, you have been handling these technology transfers and also observing the technology transfers to the private space sector. But do you think, the private sector or the industry have been very successful in utilizing these technology transfers to get a financial advantage and as well as a technical edge?
Yeah, of course. HL is one example. In the next 2 years, they are going to take the whole launch vehicle technology, which they are going to produce, and they are having a target of 12 launches per year. How
you really gauge the success of technology transfer?
So I'll come to that. Of course, that is the outcome is most important when you give hand-holding and technology transfer happens. But I will just step back and say that if the technology transfer, there are multiple ways. One is that ISRO has built the technologies and which is for their own utility, and that is being given to the technology transfer through the industry, through InSpace, through NSIL, it goes to the private company. That is what, and recently we signed the 100th TOT agreement with HCL only. And apart from that, the hand-holding is very important. And then the third thing is the technology. We are also encouraging. We have put an adoption fund for technology adoption fund for 500 crores, where we are giving 25 crores to a e-startup for building their own new technology. For the base technology can be from ISRO also, or from anywhere TL3 technology. If they take that, then they can build on that, which has of course, IRR is a very important, revenue is very important, business model is very important. So that they have to showcase, and then they can develop the technology of their own also, irrespective of from ISRO. And third thing is that we also have made a mechanism in which they can take a technology from the international partners. We are enabling that FDI, we are enabling a technology partners from the foreign sources, and then they can produce it license the technology and produce the products in India. So for that also we have created a manufacturing, we are in the process of creating a manufacturing hubs in the country. And right now we are talking about, we have mooted this idea to all the states. We got 9 states have come to us for developing their manufacturing hub, where they are giving a lot of boost to the private foreign companies also. And we are creating an infrastructure so there, InSpace is creating under Department of Space, creating infrastructure worth 100 crores, so that those companies, when they are coming here, they need not spend the same common test facilities which are required for them to repeat their facility, and the gestation period can be reduced. So these are the various ways. But of course, coming back to your question, that normally when we transfer technology, it takes 1 year for them to absorb the technology. And many successful cases are there, like MSS Type C, which was Type D terminals, which are being used for societal application. They are going into a number of lakhs of terminals. And where some places like bus elements, which which ISRO has transferred, many of the ISRO technologies for the launch vehicles, which are being produced by VSSC, they are being used by not only by the space startups or the private launch companies who are making launch vehicle, but also they have a spin-offs. And we have seen that there are a lot of applications, but definitely they have to adopt this. They cannot be used directly. Many times they are being used directly, but many times they have to they have to work extra on that and to ensure that they make it more compact, more efficient, and more in terms of even sometimes the component get obsolete, and then they have to. So, but the base technology and license is available for them to once ISRO gives the technology to them.
Thank
and
you.
Also, I want to add here one more thing. The InSpace has also created a venture fund, and 2 days back only we got the approval. Now that 1,000 crores venture fund is being available now, which will be given to all the startups through SIDBI, not through InSpace. InSpace has made a mechanism. So I suggest that all those startups who are, all those who are here, we should give this message to the startups and new entrepreneurs that this fund is only meant for the startups who want to have a courage to venture into a fund, into a space startup.
Thank you. I think we need to also give time, some time for audience to ask questions. So I'll just ask one or two more questions, but be very brief in answering. I think I'll go to Praneeth once again. You yourself are the alumnus of the IIT Madras, and the Galaxy also is IIT Madras incubated startup. So do you really think, these kind of incubations, the premier institutions, really give some distinct advantage in terms of technology and also in raising funds from the investors?
Short answer, yes. Slightly longer answer, because we absolutely because we had the access, right? So facilities like IIT Madras give you labs that it's practically impossible for a startup like us to invest and create. So having access to these laboratories, having access to a lot of students. So when we started, apart from the 5 of us, we had 7 interns working with us who were first year, second year students, right? Practically, it was impossible for us to pay salaries for each of them, but as students, that is an exciting part to us. So I think being incubated, or in our case, both being graduated and incubated, gives us a lot of advantage. One classic example is our co-incubatees, let's say, Agnikul. Now, their founders don't come from IIT backgrounds, but they got incubated at IIT Madras, and you've seen their journey, right? The rest is history for them. So they're a classic example of, even if you don't come from that background, being incubated gives you a lot of advantage. So that's where I think I'll rest.
Thank you. So maybe for the last question, I will go to Rajarajan sir. As we have seen from the presentation and also the Space Vision 2047, as India aspires to become, Viksit Bharat by 2047. So when, India would be self-reliant in heavy lift, reusable launch vehicles, maybe of something like 60 to 70 ton class?
Target is 7 years. Program is there for 8 years, but I think from 5th year onwards we'll be able to see the vehicle. And 7th year, obviously a launch from the new launch pad from Sriharikota.
Thank you. So maybe we have some 5 more minutes time, so the floor is open for the audience who would like to ask the questions. Yeah. Please give the mic there.
Sir, I am Nishant Verma, belong to Indian Forest Service and currently Joint Secretary in NRF. It is an organization which has been established by the Act of Parliament in 2024. So definitely my question is to Rajarajan sir. Leveraging artificial intelligence to augment the space technology capabilities is very important, and it is the need of the hour. And in forest department also we have various space applications with regard to natural resources management, like forest fire alert system, which is using the data, the fire alerts from the 2 satellite sensors also. So I want to know some of the key applications which have been started using EI with regard to data analytics.
First of all, I want to say thank you for putting that question to me. I'm not the subject expert anyway. There are 2 other guys who better equipped to answer this. One is Praneeth and another is Rajiv. So if you permit, I will request him to do this.
Okay, I think I can say that ISRO has a wealth of data, and they have a lot of applications which has been developed. And there is one program which is called Disaster Management Program, where such things can be addressed through them. Okay. Now, but definitely you need a lot of Earth observation data. I can say that all the data which is currently available from ISRO or the sovereign data which I talked about, EOPPP, will be made available. And also till that time, if some foreign source data is being procured by Government of India. But definitely we are also working with Gujarat government in space is working with their forest department for making their AI and based solutions. So we can connect to them And we are, with the help of ISRO and InSpace, we are trying to build a solution through a private company for their in-house solution which they want. But of course, they are using the planet space data right now, and so such solutions can be available. But I think, Prince, you want to add here because you are talking about synthetic aperture radar?
Sure. I'll not take a lot of time just to add to what Rajiv sir was also saying. We've been working with, for example, NESAC. We have SP Agarwal sir here as well. So we've had the privilege of working with them on a project of measuring forest biomass. So that's a trial that we're working on. In parallel, we're doing a lot more applications on assessing the risk of deforestation, forest fires, and so on. There are very classic applications, and in fact, I know a couple of startups who work specifically on forest-based satellite imagery and geospatial applications. So there are a lot of companies that are doing that, and certainly a very large scope that exists there.
I'm Dr. Mukesh Kumar Mena from DBT Institute, BRIC and IPGR. Okay, so my question is to Mr. Balaji. So I want to compliment HAL for contribution there in defense and aerospace industry for India. So HAL is producing this Tejas fighter jets with using US make GE engines and facing trouble in supply chains. So I want to know the status of our indigenous fighter jet engine. What is the status and timelines when we will be having it?
See, LCA is not my domain. So what I can talk is related to aerospace. And the aerospace industry, in fact, we have a state-of-art rocket engine manufacturing facility, which was inaugurated by Honorable President of India 2 years back. And I am glad to share that first module of gas generator we have produced first attempt. Industry had taken it almost 10 to 12 years. Okay, some hand-holding was there from ISRO. In fact, hand-holding was there from ISRO. But we produced it in first attempt. And hopefully, the coming financial year, we will also be one of the supporting agency for CE-20 engine for ISRO. So that's all I can tell you.
Thank you, sir.
नमस्कार सर, मेरा नाम राजेंद्र है और मैं स्पेस टूरिज्म में इंटरेस्टेड हूँ. तो मेरा क्वेश्चन ये है कि माय क्वेश्चन इज दैट हाउ डू यू सी द current status of space infrastructure for the development of space tourism in context of India? Thank you, sir.
Space?
Sorry.
Tourism.
Yes, sir.
Yeah. Always part and parcel of any system, ecosystem. Tourism will be there in space also. And we have to encourage people to experience that, no doubt about it. And there are some innovative solutions coming. And we are also trying to put it in the basket to people to come up with some innovative solutions. In VSSC, we are now trying to go to the common line and come back. As the first time, it's an experiment which we are trying to do. Obviously, start with will be uncrewed, and then how to put the human. So it will be an offshoot of our Gaganyaan and other programs. That possibility exists. But we have to now take it, see the technology, and we have to put it so that the ecosystem can be developed. It is possible, no doubt about it.
Myself, Atul Kumar Singh. My question to Mr. A. Rajan. Sir, for the DEP space program, ISRO has something planning for that nuclear thermal propulsion. So what is the amount of thrust we are planning and first stage? So that I want to know.
Yeah, as Chairman he already pointed out, yes, it is a program, it's under development, and it is going on in collaboration with obviously the subject experts and the domain experts available within India. There are 2 departments working on. So with that, a proportion is definitely on. The rest of things, it will come naturally as it comes. It will come into the domain. So it is definitely on. And for the deep space, it is one of the most important, almost you can say as on today, it's a mandatory requirement, other than over and above the electric, plasma propulsion, or whatever we call it. So,
in first stage, how much thrust we are looking for?
no, I don't want to get into all those aspects.
Okay, okay.
Yeah.
Thank you,
Sir, I'm Colonel Nirav. And,
yeah, maybe just last question. Yeah.
Yeah, I'm Colonel Nirav, and I represent a small user segment known as the strategic users. So my question will be specific to two domains. Like if you scan the events of last year, somewhere we have seen that the extended C, which is the mid-band C section, that has been actually reformed for the, I would say, telecom usage. Now what that has done, it has deprived the strat user of that particular segment in which very stable links were there. So firstly, and now it is expanding towards the reforming of C-band also. So I would like if some panelists can give a comment on this. And my second and pointed question would be regarding the usage of X-ray band. Like if you look the world across, X-ray band is utilized in a communication which is not present in our Indian X-band, which is not in India. So maybe a small comment on these two aspects. Thank you.
I'll answer your question. I think the first point which you mentioned, we can discuss that because this is for, as you said, for the strategic, we need to discuss. We have a forum where we have a discuss. We have created this DOT, ISRO, InSpace, and all discuss about the communication. And this we will discuss on the sideline. Don't want to answer here. On the second, X-band is being used for, right now being used for not communication, but for data download for all the ground, all the Earth observation satellites, and also being used for our all the
radar imaging.
Radar imaging, yes. So radar imaging. So I think I don't know. We can, if anything merit is there, definitely we are cannot be depriving any of our user or the service provider to use it. We can discuss that what band you are. I don't think we currently being used for X band. We have a spectrum of K band. We have even people going to even 60 gigahertz and beyond in optical and all that. But X band, I have not seen that people are using it for terrestrial communication or for your any other set. But definitely we are using it for communication from data links, for which we are communicating from the satellite to the ground. Okay. Shantanu, if I have just want to take 1 minute or half a minute. Okay. So responding to the question which was talking about the application for forest services. So we also have a seed fund from InSpace, which we are giving to the private companies, where we are developing applications, only applications for various needs. So we have already floated 4, one on marine sector, agriculture, and also on the urban planning. And right now we have identified 4 problems we discussed with the ministry, agriculture, the NDMA, and also with the Ministry of Power, and we have defined those problems and given to the industry. So once those applications are developed, these are done in consultation with ISRO, because that means it was not existing those things. So the point which I'm saying is that there is a provision for even developing applications which can be scaled once it is developed for the user or for the country's requirement, for the ministry requirement or for any. Thank you.
Thank you very much. I just maybe sum up this entire thing in maybe 2-3 lines. Of course, we have seen the the technical session in the morning, how India has achieved the self-reliance, in space capabilities, indigenous space capabilities, through cutting-edge research, the frugal innovation and all. And of course, now when there is a shift from the government, funded model of the space ecosystem, to make it more stakeholder oriented and more inclusive. We have seen how it has given momentum, of course, to the private sector to innovate in all domains of space activity. It is not only limited to building launch vehicles or the satellites and all. We also seen that people are also now more into the data analysis part and giving very much informative, knowledgeable products for the decision makers. And you are seeing, of course, one entrepreneur sitting here. We have heard many startups in various forums. In one startup, I happened to be there, and I have seen 25, private industries were there, particularly on the space activities, only in the delivery of data and the information products. And I have seen all 25 were not having any sort of overlap between the activities. So it really only shows that how much opportunity is there It is left to your imagination how the private industry really can utilize this space data and deliver those space-based services. So I think this kind of conducive ecosystem in place, I think coming years also we will see the Indian space sector will surely witness more rise of these agile and technology-driven startup companies, which will not only drive the scientific progress, but also will fuel the transformative innovation and also foster the collaborations and contribute to the global space economy as well. So I'm extremely thankful for all the distinguished panelists here for sharing their thoughts with the audience, and very much thankful for all the delegates for their patient hearing and making the session interactive. Thank you very much.
Thank you, panelists, for making this session so lively up to, though we have crossed our time limit too much. Now I request Shri Kiran Kumar sir to just come on the dais and facilitate our panelist and moderator. I also call upon our committee member who are present. I am seeing Senthil Kumar sir is there. Please come on, sir. PP Sahaji. No, no, वो तो